This is Advanced Math, Unit 6, Lesson 3. Angle addition laws. And solving continued. Okay, so today we're going to review some of the stuff we've been doing so far, so that's a good thing after the break. First thing we're going to review is the formulas: sine of A plus B, cosine of A plus B, and tangent of A plus B. If you'd like, you can hit pause and write them out on your own, see if you still have them memorized. Okay, so what we've said before, sine is the friendly one. It's the one that hangs out with cosine. So sine of A, cosine B, same sign, plus sine of B, cosine of A. We talked about cosine being the snobby one. It hangs out with only itself. So cosine A, cosine B, opposite sign, sine of A, sine of B. And tangent's the only one that's a big fraction, and it's kind of like what you see there, A plus B. So it's tan of A plus tan of B all over one opposite sign minus the product of tan of A and tan of B. I'm not going to put the minus signs in there, but if that was minus, this would be minus. If that was minus, this would be plus. And if that was minus, then it would be minus plus. Okay, so I'm hoping you guys are working on these because we will soon be learning a whole new set of formulas that we will need to have memorized. So again, working on these. All right, solve for x. Number 1, sine of 2x cosine x plus sine of x cosine 2x equals -1. Okay, our previous lesson, we talked about expanding and solving. Let me show you really quick what I'm talking about. We had stuff like this, and then we expanded to this one, we expanded the second one, and simplified. Now recognize when you're expanding versus condensing. Can you see, first off, there's no like terms here? Because these two are sines, but this is a 2x and this one's a 1x. There's two cosines, but one's an x and one's a 2x. So there's no GCF, there's no like terms. But there is, this is the expanded form of your sine formula. Can you see that? Sine, cosine, sine, cosine. So we're going to condense it to the sine. Sine of A and same sign plus B. Remembering A is always with your first sign, so sine of 2x plus x. Now technically it wouldn't matter which one you put as A and B because it's a plus sign, but if it was a minus you would have to be careful. Okay, so now we can combine and we get sine of 3x equals -1. And this is something that we have seen before. 3x equals, and we think the 3x means we're going 3 times around. At what angle is sine -1? There's only one place, and that is 270. And 3, so since there's only one, I'm going to have a total of 3 sets, giving me only 3 answers, not 6, because my first is only 1. So 270 plus 360, this number plus 360, and then all of those divided by 3, including the first one. All right, so 270 plus 360 is 630. 630 plus 360 is 990. And then you go through and divide, and you get 90 degrees, 210 degrees, and 330 degrees. So if you were to plug any one of these angles in for your x's, it would come out to be -1. Okay, number 2. cosine 2x divided by sine x plus sine 2x divided by cosine x equals 1/2 secant x cosecant x. Now kids will often try to say, oh, this reduces to 1. No, secant and so cosecant are not reciprocals of each other. All right, so this does not reduce, but we're trying to solve. There's no GCF, but I can clear my fractional equation because it's an equation. It does not have to be a complex fraction. Because it is an equation, I can multiply both sides by the common denominator, and the common denominator being sine x cosine x. Sine x cosine x. All right, so I multiply everything on both sides of the equation by sine x cosine x. Sine x reduces, leaving me with cosine 2x cosine x plus cosine x reduces, leaving me with sine 2x sine x equals, and here I have 1/2. Now noticing that secant times cosine and cosecant times sine, all of that's going to reduce to 1, so I have 1/2 times 1, which is just 1/2. Okay, why is the 1/2 left? Again, because sine and cosecant reduce to 1, cosine and secant reduce to 1, leaving me with 1/2 times 1, which is 1/2. Okay, recognizing this to the last one, that it is a condensing formula, cosine with cosine, sine with sine. Is this the expanded form of sine or cosine? Cosine, because it's the snobby one. So you condense it to cosine, opposite sign minus, and then I have 2x minus x equals 1/2. Cosine 2x minus x is x, equals 1/2. All right, cosine of what angle? It's only 1x. Cosine of what angle is 1/2? My reference angle is 60 degrees. Is 60 degrees one of the answers? Yes, because it's positive. Quadrant 1, 60. Quadrant 4, 300, because those are the two places where cosine is positive. Okay, a quick side note. Earlier, I said A is always with the first sign, and I didn't specify that here. Is A always with the first cosine? And if there's two cosines, how do you know which one is A and which one is B? Here, it's easy to tell because sine, cosine, there's two different functions. Sine is A, cosine is B. Here, how do you know? What happens if you flip them around? Let's quickly do that here and see what happens. What if I did cosine of x minus 2x? What if I did write this as cosine x cosine 2x? This was A and that is B. What would happen? Cosine of x minus 2x is cosine of negative x equals 1/2. And remember what cosine does with the negative? Does it kick it to the front or absorb? It absorbs. So cosine of x equals 1/2. I'd end up with the same equation. So with sine, it's tricky. When it's a minus with sine, you do have to make sure you have the proper A and the proper B. With cosine, it doesn't really matter when it's minus because cosine absorbs the negative. It's going to work out either way. Okay, moving on. Number 3. This one is on the test, by the way. And it's one that kids miss a lot because you have to write out a written explanation, and a lot of kids don't like that, but you should be used to that from your Math 1, 2, 3 Common Core classes. Sine of A equals -5/13. Cosine of B equals 3/5. Neither A or B are in quadrant 4. Neither A or B are in Q4. Okay, so let's write this out. Let's draw our pictures. We had one similar to this in a previous lesson. Here's A, here's B. I haven't asked you the question yet. I'm going to ask the question after I draw the picture. Okay, neither A or B are in Q4, so I'm going to go ahead and cross out Q4. Sign is negative. Well, sign is positive in these two, so those two are gone. That leaves quadrant 3 is the only quadrant A can be in. Okay, B, cosine is positive. Well, cosine's positive in 1 and 4, so the only place it could be in is quadrant 1. Okay, sine of A is negative 5 over 13, opposite over hypotenuse. Pythagorean's theorem, you get negative 12 for this leg here. B, cosine of B is 3/5, adjacent over hypotenuse, positive 3 over 5 as your hypotenuse. And sorry, I forgot to specify here that when you do Pythagorean's theorem, you do get a positive 12. You just need to know that it's negative because it's going in the negative direction. You do need to be careful with that. Okay, this is a 3, 4, 5. That's positive, so it's positive 4. Okay, now that we have our picture, this is the kind of stuff they're going to ask you on the test. Part A, what is sine of A plus B? Okay, that question we've already had. What is sine of A plus B? We use our angle addition laws to expand it and figure it out. Sine of A, cosine of B, same sign, sine of B, cosine of A. So we just use our pictures. For sine of A, I'm going to go here, and I can also use that. It's negative 5 over 13. Cosine of B, I'm going to go here, or I can use the 3/5. Plus sine of B. Now I'm on this picture, and it's sine of B. I was never given sine of B, so I do need to use my picture. It is 4/5. Cosine of A, I do need to use my picture. It's negative 12 over 13. So this gives me negative 15 over 65 plus negative 48 over 65. Add the two negatives together, negative 63 over 65. All right, that part most kids can do okay and not struggle with too much. It's part B where they tend to struggle. And here's the question. In which quadrant is the terminating ray of A plus B? Okay, terminating ray, remember this is my terminating ray here for B. Here's my terminating ray for A. Once I add angle A and angle B together, where does my terminating ray end up? In quadrant 1, 2, 3, or 4? Now, you cannot say, well, it can't be in quadrant 4 because it said that here. This up here, the statement they give you that neither is in quadrant 4 is only for the original A and the original B. Has nothing to do with this question here. So in the explanation section, if you say, well, it can't be in quadrant 4, so it must be in blah, 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 you're going to get it wrong. Okay? So again, do not use this given information because this is only relevant to A by itself and B by itself. Once you add it, for example, B may be big enough where it bumps it over, where when I add it to A, it bumps it over to quadrant 4. It may be just small enough where it leaves it still here, like I barely add on to the A, and here's my new terminating ray, so it's still in quadrant 3. We don't know. It could be in 4, it could be in 3. It could be big enough, depending on the measure, it could be coming around this way where it bumps me out. So all in all, we don't know. We have to figure that out. Okay, so here is what we have to do. We have to first ask ourselves, what do we know? Let's write that down. What do we know? We know this right here. Sine of a plus b came out to be a negative number. That is important. If what we're looking for is a plus b, the terminating ray. Well, we know sine of a plus b came out to be negative, and we know all students take calculus. So if sine is negative, what two quadrants can I automatically cross out? First one and second one. Why? Because all are positive, sine is positive, so it can't be in either one of these quadrants. So that leaves me with 2 or 4. Now, if on the test you do this and you say, oh, and you stop here and you say it must be in quadrant 3 because blah, 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 here it's negative, so it can't be in quadrant 1 and 2, and it can't be in quadrant 4 because it stated that in the beginning. Wrong. Remember, we do not use this given information for part B. Okay, so this is what we know. What do we need to know? We need to know which quadrant it is in between these two. So the only other functions we have for these a plus b is cosine, cosine and tangent. So we can figure out what tangent of a plus b is or cosine of a plus b. I would do cosine only because it is easier. We need to know whether it's positive or negative. If cosine is positive, then it's in quadrant 4. If cosine is negative, then it is in quadrant 3. So we have enough tools right now to find cosine of a plus b, because that was given to us, a plus b. So cosine a, cosine b, opposite sign, minus sine of a, sine of b. All right, I'm going to write these out quickly. You can put pause and figure them out on your own and then hit play and see if you have them. Negative 12 over 13, 3/5. Negative 5 over 13, 4/5. Giving me negative 36 over 65. Take away, that's negative 20 over 65. Add the opposite, those two negatives make a positive. So I have negative 36 plus 20 because they already have a common denominator. You know what? I don't even really care what it comes out to be. All I care is this a positive number or a negative number. And negative 36 plus 20 will give me a negative number. Do you see that? Now we know it's negative, which means what? If sine of a plus b is negative, it can't be in these two quadrants. That leaves me with these two. If cosine of a plus b is also negative, it can't be in quadrant 4 because that's where cosine is positive, leaving me with quadrant 3. Okay, so on the test, they will ask you to explain. And you'll have a little section there to write out your written explanation. So you can say, you would say what we knew, sine of a plus b is negative, and cosine of a plus b also came out to be negative, which is not always going to happen. One might be negative, one might be positive. In this case, they both came out to be negative. Therefore, it must be in Q3. All right, so what was the answer? Which quadrant is it in? Quadrant 3. There's two parts to this answer. On the test, they'll give you a blank to tell me which quadrant it's in, and there'll be some blanks to write down the written explanation. So on your first blank, you'll say Q3, why, and then you would give all this. And I don't care if you write it as a Roman numeral or just a number 3. It's totally up to you. So this will be one answer, and then this will be your written explanation. Because sine of a plus b is negative and cosine of a plus b is negative, therefore it must be in quadrant 3. This again is the hardest part that kids struggle with. We will do another one together in class, remembering this is on the test. All right, that's it for this lesson.